everybody. So today we are doing a lot, but it's doable, so don't panic. We are going to be taking notes on radian measure, arc length, and area of sectors. So if we were in school, I would have done a little activity with radian measure showing you exactly how radians are calculated and what they are. We're just going to learn the formulas. Since I'm not there to help you, I'm using like a ton of highlighters, like all the colors that I have. So if you want highlighters or colored pencils or something, go ahead and grab them. Let's see, get my last one. Yeah, so hopefully me being super detailed through this will help, and like tons of labeling and whatever. Okay, so let's get started. All right, so radian measure, arc length, and area of sectors, also both the solutions and the blank copy are posted, linked to this little activity box. Okay, so we're starting with radian measure. So usually we measure angles in degrees. However, when we are setting circles, it is much more convenient if we express angles in a different way, radians. So there are two things that we need to know here. They're like just basically proportions, and it's converting from degrees to radians and radians to degrees. So if we're converting from radians, or if we have degrees basically, and we want to convert to radians, we want to isolate radians, the R right here, we use this formula. It's D, the degrees that we had, times pi, 3.14, divided by 180. So we just divide the degree by 180 and attach the pi at the end. That's all. Okay, so in these practice problems right here, we are converting from degrees to radians. We're using that formula. The next formula is to convert from radians to degrees. So now we have degrees isolated, and we're going to multiply our radian measure that we're given by 180 and then divide by pi. So we're doing the opposite of what we did before. That is what we're doing in these practice problems. Okay, so let's go ahead and practice. So here we convert from degrees to radians. So we're given this degree measure, and it's 270. And I'm multiplying by pi over 180. Okay, now when I want to keep the pi in it. Okay, so when we have radians, we want our pi to be there. So I take 270 and I divide by 180, and I should get 1.5. Now you can do this fancy thing on your calculator where you click the math button and then enter, and it should turn your decimal into a fraction. So this happens to be 3 halves. And then we need to attach our pi that we didn't put in the calculator right there. So 3 halves pi radians, 3 pi over 2 is equivalent to 270 degrees. Okay, that's all we're doing with this whole thing. So let's keep going. So now we have 60 degrees. So I'm taking my 60, I'm multiplying by pi over 180. Now 60 over 180, that's kind of like 6 over 18, right? 6 times 3 is 18, so I should just get pi over 3 for this one. If you can't do those fractions in your head, that's totally fine. Type 60 into your calculator, divide that by the bottom number, 180. Oops. Click enter, you get 0.33333. Click math, enter, and you get 1/3. So we should have pi over 3 radians right here. Okay, so this was our solution, and this was our solution. Next, we have 150. Oops, didn't mean to do that. Of course, 150 is equal to 150, but that's not what we're trying to do. So 150 times pi over 180. So we take 1, move this up so you can see it. Zoom in a little bit. 150, divide by 180, math, enter, and you should get 5 pi over 6. 5 over 6 pi radians. Okay. Then if we move on to D, we have 30. So we should have 30 times pi over 180. 30 divided by 180 is, math, enter, 1/6. So we get 1/6 pi. So this is pi over 6 radians. Okay. Let me circle my answers or box in my answers. Okay, I'm actually going to leave E and F as you-dos for you. The solutions, though, are posted on the solutions notes attached so you can find the answers. Okay, so do E and F as your own practice and then check your answers on the solutions sheet that's attached below. Okay, so next we're converting from radians to degrees. So we're doing the opposite. So every time up here, we multiplied by pi over 180. But down here, we're going to multiply by the opposite, or the reciprocal. Okay, the reciprocal means you flip the fraction. Okay, so we're multiplying by 180 over pi. So here, I have pi. So I'm taking that pi and I'm multiplying by 180 divided by pi. Now, because I have a pi in the numerator and denominator, I can cross these out and I should just get 180 degrees. Okay, so that's my answer for that one. Here I have pi over 2. I'm taking my value that I was given. Then I'm multiplying by the reciprocal. So I'm using like this piece right here, 180 over pi. My pi's cancel out. 180 divided by 2 is 90. So I should have 90 degrees is equal to pi over 2 radians. So notice here, it's the 180 over pi that changed. Okay, so that's what's different about each of these formulas. We're multiplying by pi over 180 in the orange, 180 over pi in the second. So now we have pi over 4, multiplied by 180 over pi. Pi's cancel conveniently, and then 180 divided by 4 is 45. So I should have 45 degrees right here. I'll do one more with you, and then I want you guys again to do E and F as a you-do, and check your solutions below. Okay, so here we have 3 pi over 4. We're multiplying by 180 over pi, canceling out our pi. Now 180 divided by 4 is 45, just like we saw last time, but then we're multiplying that by 3 to get 135. So again, what we did here is we took 3 over 4 and we multiplied that by 180, 135. Okay, so I should get 135 degrees right here. Okay, so that's where this came from. All right, do E and F as you do, or this is supposed to be an F. I apologize. F. Okay, so do those as you do's and then check your answer.